Okay, in this video we're going to look at two types of equations to solve. So we're going to look at radical equations. So typically they're going to have a square root or a cube root in them. So the guidelines are to isolate a radical, square or cube both sides, and that's going to undo the radical. If there's still a radical left over, go ahead and go back to step one, isolate a radical. If there's no more radicals, then you can go ahead and solve it. And like any equation that has variables in the denominator, if we have variables inside a radical, we will need to check our solution, make sure they actually work out. Okay, so let's go ahead and look at the first one here. So we got the square root of x minus 7 is equal to 5. And so to undo that square root, we're going to square both sides of the equation. The square and the square root will undo each other, so that frees the x minus 7 from the square root. That's going to be equal to 25. We'll add 7 to both sides of the equation, and we get x is equal to 32. We'll plug that in to the original equation, make sure it works out. 32 minus 7 under the square root is the square root of 25. That's equal to 5, which is what the equation said it should be equal to, so you can give yourself a check mark and a happy face if you want to, because it checks out. You don't have to. Let's look at another one. Say we have x plus 4 under the square root equals to negative 2. And square roots are, later on we'll talk about the domain of the radical function, and that's going to be 0 to infinity. And the range is going to be 0 to infinity. So it will not be equal to a negative number. We don't know that quite yet, so when we go through the process, we'll square both sides. We get x plus 4 is equal to 4. We'll subtract 4 from both sides, and we get x is equal to 0. And so when we check that, 0 plus 4 under the square root, that's going to be equal to 2. So we won't have the plus and minus unless we're in the act of solving, like you square root both sides of an equation. That's where you get the plus or minus. So when we're just taking the square root of a number, that's understood to be taking only the positive root, or what's called the principal root. So we get 2, but that's not equal to the other side of the equation, which is negative 2. So that is a no solution. And we may also say that is does not exist, so sad times. So if your square root is equal to a negative number, that will be a no solution because of the range of the square root function. Okay. All right, so let's move on. We're going to look at, I think, 3 more examples of radical equations. We'll kind of ramp up the level of difficulty. So here we have 3x plus 18 under the square root equals x. We're going to go ahead and square both sides of the equation to undo that square root. So then the 3x plus 18 is free. It's equal to x squared. So out pops a quadratic. So how we solve a quadratic is setting it equal to 0 and crossing our fingers that it factors. Okay, so 0 is equal to x squared minus 3x and minus 18. And that's going to go ahead and factor into x minus 6 and x plus 3. And so we will check, and we will get x is equal to 6 or negative 3. And then we'll go ahead and check those answers. So we're going to plug in 6. 3 times 6 plus 18. And then on the other side of the equation is x, so we're going to plug in a 6 there. We're going to just work that out and see if that's the same. The left-hand side is the square root of 36. Right-hand side is 6. 6 is equal to 6, so this is true. So x equals 6 is good. Then if we check negative 3, 3 times negative 3 plus 18 under the square root, is that equal to negative 3? Negative 9 plus 18 under the square root, is that equal to negative 3? Is the square root of 9 equal to negative 3? That's asking you, is 3 equal to negative 3? Nope, that's false. And so we're going to go ahead and throw that answer out. So with these radical equations, if you do get two answers, oftentimes one will be good, one will be bad. Sometimes both are good, sometimes both are bad. Let's go ahead and look at another one. So here we have x plus 149 under the square root equals x plus 17. The radical is already isolated, so we'll go ahead and square both sides of the equation. And the right-hand side, we're going to have to FOIL that out. Okay, left-hand side is x plus 49. X times x is x squared. Then you'll have an x times 17, and then a 17 times x, so those will be two 17x's, add together will be 34x. 17 times 17 is 289. This is quadratic, so we will set it equal to 0 and cross our fingers that it factors. So we'll subtract x and subtract 49. Okay, once we've done that, we have 0 is equal to x squared plus 33x, and then minus 140. So I'm going to write the factors of 140, or at least start. 1 times 140, 2 times 70, 4 times 35, 5 times 28. 5 plus 28 will be 33, so that's what we want there. So 0 is equal to x plus 5 and then times x plus 28. So that'll give us two answers. X is equal to minus 5, or x is equal to negative 28. Okay, so negative 5 and 28. We'll run our check. First we'll check negative 5. Negative 5 plus 149 under the square root equals negative 5 plus 17. The left-hand side will be square root of 144. Right-hand side will be 12. 12 is equal to 12. So check mark and a happy face. That answer is good. Now we'll check minus 28. Negative 28 plus 149 under the square root, is that equal to negative 28 plus 17? Square root of 121 equals negative 11, so 11 equals negative 11. That is false. So sad face, and we throw that answer out. So negative 28 is no good. Okay. All right, so we're going to look at one more radical equation, and number 5 is probably about as difficult as they get. And what makes it a little bit difficult is we have two radicals. So we have the radical x plus 3 equals the square root of x plus 12. And so this is why the first step of the guidelines for solving these says isolate a radical. So we have a radical isolated. It's the x plus 12 under the square root. So we can go ahead and square both sides. So square both sides. And we're going to FOIL the left-hand side. The right-hand side, the x plus 12 is now free from the radical because the square undoes the square root. Square root of x times square root of x is the square root of x squared. Square root of x times 3, 3 root x. 3 times square root of x, 3 root x. 3 times 3 is 9. That's going to be equal to x plus 12. Okay, so we'll do some simplification. The square root of x squared is x. 3 root x and 3 root x is 6 root x plus 9 equals x plus 12. So our guidelines, I think, were to isolate a radical, square or cube, depending on what we had. So it looks like we're only looking at square roots. Once we've done that, then we need to isolate a radical again. So this time the radical is the 6 and the square root of x. We can include all of it. It's really just the square root of x, but that's the term we would like to isolate. So to do that, we need to subtract x and subtract 9. And we have 6 square roots of x is equal to 3. Now, you got a choice here. You can square now because that's one term. 6 square roots of x, you can go ahead and square that. If you divide by 6, you're going to have a fraction, and we're going to end up getting a fraction either way. So I would say 6 square root of x is isolated enough. So we'll go ahead and square both sides. And 6 squared is 36. Square root of x squared is x. That's equal to 9. Divide by both sides by 36. So that tells us x is equal to 1/4 after we reduce. Go ahead and check that. Square root of 1/4 plus 3 equals square root of 1/4 plus 12 under the square root. And so we don't know if this is true or not, so we're just going to go through and work it out. So that'll be 1/4 plus 3 I'm sorry, not 1/4. The square root of 1/4 is 1/2, excuse me, plus 3. 1/4 plus 1/12, 1/4 plus 12. 12 over 1 is the same thing as 12. If we wanted to have a denominator of 4, we had to multiply the denominator by 4, so we need to multiply the numerator by 4, so 12 times 4 is 48. Okay, so 1/4 plus 48. 1/4 plus 48 over 4 is 49 over 4. 3 over 1 is the same thing as 6 over 2. So 1/2 plus 6 over 2. That's going to be equal to 7 over 2. So we have 7 over 2 is equal to 7 over 2. That is true. And so we give ourselves a check mark and a smiley face. That answer does, in fact, work out. All right, let's go ahead and move on to the next type of equations, which is what we call equations in what's called quadratic form. We're going to use we'll call it U substitution, and that will make something that looks a little bit more complicated, less complicated, so we can go ahead and factor. So something's going to look like it's in quadratic form if it looks like AU squared plus BU plus C equals to 0. And we'll use a U substitution to kind of help this out. So number 6 says 2 times the quantity x plus 3 quantity squared plus 11 times x plus 3 quantity plus 15 equals to 0. So notice that you have the x plus 3's twice there. One of them squared. So this kind of looks like 2x squared plus 11x plus 15. It doesn't quite look like that because it's x plus 3 instead of just x. But that's going to help us out with the U substitution. Usually with the U substitution, we're gonna take the smaller exponent if it's positive. So the smaller exponent is 1 here, so that's going to help us with our substitution. So we're going to let U equal x plus 3. So we're going to let U equal x plus 3. Then if we square U, so we're going to sound silly, when we square U, you're going to be x plus 3 quantity squared. So this equation now becomes 2u squared plus 11u and plus 15 is equal to 0. And now we're going to go back to trying to solve this by factoring. So we'll set up our diamond. AC is 30, the B is 11. The factors are 5 and 6, so 2u squared plus 5u plus 6u plus 15 is equal to 0. So what we're doing here is we're going to do this by factor by grouping. Maybe you can factor it with guess and check. That would certainly be fine. First two terms have a u in common, 2u plus 5. Second two terms have a 3, 2u plus 5 equals to 0. So we have 2u plus 5 times u plus 3 equals 0. So that says u is going to be negative 5 over 2, or u is equal to negative 3. Okay, negative 5 over 2 is negative 2.5 if we want to do the decimal. Okay, so in this problem we're using u to help make the problem a little bit simpler. So at the end of the day, we don't want u equals, we want x equals. So what we're going to do now is replace the letter u with what it was equal to, and that's x plus 3. So x plus 3 is equal to negative 5 halves, or x plus 3 is equal to negative 3. Both equations you'll solve by subtracting 3, so x is going to be equal to negative 5.5, or that would be the same thing as negative 11 over 2, or x is equal to negative 6. So those would be your two answers. The alternative for solving this type of equation is you could expand out the x plus 3, and so you'd have to FOIL this out, distribute the 2 through afterwards, distribute the 11, and it'll work out. It's a little bit more messy though. Okay, so the U substitution's meant to kind of help things out, make it a little simpler. Okay, number 7 here we have x to the 4th plus x squared minus 20 equals 0. So what this looks like to me is x squared plus x minus 20 equals to 0. Okay, that's what our U substitution is going to end up looking like. So we're going to pick on the smaller exponent, which is 2, and that's going to be our u. So u is equal to x squared. u squared will be x squared quantity squared, and when we raise an exponent to an exponent, we multiply them, so 2 times 2 is 4, so that gives us x to the fourth. So replacing everything, we have u squared plus u minus 20 equals 0. Okay, so product of negative 20 that adds up to 1 is going to be positive 5 and negative 4. So that's going to tell us that u is equal to negative 5 or u is equal to 4. Okay, u is x squared. U is x squared, and so x squared is a negative 5, or x squared is equal to 4. And to solve this, we're going to go ahead and take the square roots of both sides. Don't forget your plus or minus. Don't forget your plus or minus. X is equal to plus or minus I root 5, or x is equal to plus or minus 2. Okay. Let's see, we got 2 more to look at. Number 8's probably the most crazy out of the problems we're going to look at. 9's got some negative exponents, so that can be kind of tricky. Okay, so number 9, we have x over x plus 1 quantity squared plus 20 times the quantity x over x plus 1. And that's equal to negative 99. Okay, so I do see the x plus 1s are in common. So what I'm thinking I'm looking at is an x squared plus 20x equals negative 99. And so I'm going to have to add the 99 to both sides. X squared plus 20x plus 99 equals to 0. So I get x plus 11 and x plus 9 is equal to 0. So that's where I'm going to go with this. I got to first do my u substitution, so it'll take this crazy looking problem and make it look a little nicer. Okay, and so let's go ahead and get that u substitution going. Okay, so u are going to be x plus 1. When we square u, you're going to be x over x plus 1 quantity squared. So this now becomes u squared plus 20u equals, well, and then I'm skipping a little bit of steps here, but I added 99 to both sides. Okay, factors into u plus 9 and u plus 11. So u is minus 9 or u is negative 11. Replace the u with x over x plus 1. And so x over x plus 1 is negative 9, or x over x plus 1 is equal to negative 11. We'll go ahead and clear the fraction. The common denominator is x plus 1, so multiply both sides by x plus 1. Okay. On both equations. So we will have x equals negative 9x minus 9, or x equals negative 11x minus 11. Add 9x to both sides. 10x is equal to negative 9. Divide both sides by 10, and we get x is equal to negative 9 over 10. On the second equation, we'll add 11x to both sides, and we will have 12x is equal to negative 11. Divide both sides by 12. X is equal to negative 11 over 12. And I didn't find my restriction here. The restriction is we have a denominator with an x. That's the x plus 1. So we'll go ahead. You can find your restriction at the beginning or the end or any time, really. X plus 1 cannot be 0, so x cannot be negative 1. That's neither of our answers, so both our answers are just fine. Okay. Let's look at one more, and this one will have some negative exponents. So x to the minus 2 minus 8x to the minus 1 plus 15 is equal to 0. So to me, this looks like x squared minus 8x plus 15 equals 0. And so again, I'm going to want to solve this by factoring, okay? Now, I've been saying go with the smaller exponent, and that's when they're positive. And if they're negative, you want to go with the, I guess, we'll only look at the numbers. So if we want to get technical, we would say absolute value. But let's look at the numbers 2 and 1. well, it's really -2 and -1, but out of 2 and 1, which one's the smaller one? That's the -1. So out of the 2 and the 1, the 1's the smaller. So anyways, u is equal to x to the -1. U squared is x to the -1 squared, and you multiply those exponents and get x to the -2. So we'd have u squared minus 8u plus 15 is equal to 0. Go ahead and factor that. U minus 3, u minus 5, equals 0. U equals 3, or u equals 5. So we're not interested in solving for the letter u, we want to solve for the letter x. Well, u is x to the -1. Recall that b to the -n is 1 over b to the n, so that means x to the -1 is 1 over x. So you'll have 1 over x is equal to 3, or 1 over x is equal to 5. They both have a common denominator of x, so we're going to multiply both equations by x. So 1 is equal to 3x, or 1 is equal to 5x. Divide by 3, divide by 3. 1/3 is equal to x, or divide by 5, divide by 5. 1/5 is equal to x. Go ahead and box this. Your restriction is you do have a denominator. It's going to be x, so x cannot be 0. So the x to the -2 is equal to 1 over x squared. The x to the -1 is 1 over x. So they both have a denominator of x, so x cannot be equal to 0. There's another way we could solve this equation if we rewrote them as 1 over x squared, -8 over x plus 15. You could also clear the fractions. That'd be an alternative route here. But our focus for this one is to do several different applications of the u substitution. I believe I might have another video or two on the u substitution and also the radical equations. Just check my Unit 1 playlist on my YouTube channel. Okay, so that concludes this video.